MICO designs, manufactures, and sells hydraulic components and systems for heavy-duty off-road vehicles and equipment. We have been providing our customers with quality hydraulic braking technology and services for over 50 years. Welcome to our series of MICO product training presentations. This presentation covers full power brake systems, the advantages, as well as how and why they work the way they do. We felt that this information was important to understand before getting into the training on our line of full power hydraulic brake components. Let's get started by explaining what exactly a full power hydraulic brake system is. Full power hydraulic brake systems use flow from a hydraulic pump or hydraulic accumulator to operate the brake system and other hydraulic components. This type of system serves as a direct means of supplying hydraulic pressure to the brakes. The fluid in these systems is typically hydraulic oil. It can be filtered and provides low maintenance operation. Full power brake systems allow the operator to be more of a controller and less responsible for providing manual force to accomplish braking. Full power brake systems can be either dedicated or non-dedicated. A dedicated system is when the brake system pump supplies only the demands of the brake system. A non-dedicated system is when the pump supplies the demands of the brake system as well as some secondary downstream hydraulic device. Full power brake systems will vary in sophistication with the various types of hydraulic systems available. The most common systems in use today are open center, closed center, and load sensing. The full power hydraulic brake system has several advantages over traditional brake actuation systems. First of all, fluid displacement is not limited by an actuating component, such as a master cylinder. These systems are also capable of supplying fluid volume to service brakes ranging from very small to large. The maximum brake system pressure is limited by a pre-adjusted setting. It is not possible for the operator to cause the brake system to exceed intended pressures, as can happen with master cylinders or two fluid valves. Full power systems can also supply significantly higher brake pressures with relatively low reactive pedal forces. The reactive pedal force felt by the operator would be proportional to the brake line pressure being generated. This is referred to as brake pressure modulation or pedal feel. Full power hydraulic brake systems use one or more accumulators to store potential energy. A properly sized accumulator is able to provide power off braking identical to power on braking. Consult MICO to properly size accumulators for your specific application. Accumulators can also be used for limited applications to provide higher flow requirements than can be achieved by the pump alone. They can be used as a shock absorber in a hydraulic system. Accumulators come in a variety of types and sizes. A typical accumulator works similar to the drawing shown here. A low-pressure warning switch is used in full power systems to sense accumulator pressure. In the event pressure in the accumulator drops below a safe operating level, the operator is alerted through a visual or audible device. Here are some samples of MICO low-pressure warning switches. Braking applications using an open center hydraulic system will contain as a minimum a hydraulic pump, accumulator charge valve, a relief valve positioned between the pump and accumulator charge valve, accumulator, a low-pressure warning switch, a modulating brake valve, and service brakes. Depending on the requirement, the brake circuit can either be a single or a dual. In an open center hydraulic system, the pump supplies fluid to the accumulator charging valve. The charging valve is used in conjunction with an accumulator and modulating brake valve. The charging valve controls the charging rate of the accumulator and the pressure of the fluid in the accumulator. The charging valve automatically stops charging the accumulator when the preset high pressure setting is reached. As the accumulator displaces its charged pressure when the brakes are applied, it will eventually reach the charging valve low pressure setting. At this time, the accumulator charging valve allows a small amount of fluid from the main open center hydraulic system to charge the accumulator. In an open center full power system, the portion of the system from the accumulator charging valves to the service brakes is a closed center circuit. The charging valve charges the accumulator upon demand, operating within its preset charge rate and maximum pressure setting. However, in a non-dedicated system, if the downstream open center circuit causes the main system pressure to exceed the charge valve high pressure setting, the accumulator will be charged to this higher pressure. The primary advantage of the dual charging valve over the single charging valve is that if half of the brake system fails, The remaining half will continue to function. A full power brake circuit that is incorporated in a closed center hydraulic system is typically a non-dedicated circuit. The pressure-compensated pump that supplies fluid to the brake system almost always supplies fluid to some other system requirement as well. The closed center hydraulic system will contain as a minimum a hydraulic pump, a non-return valve, a low-pressure warning switch, a modulating brake valve, and service brakes. In these circuits, the pump provides fluid displacement for power-on braking, and the accumulators provide the energy source for power-off braking. It is important in these systems that the pump can provide all volume requirements, so the brakes never suffer a lack of fluid. Load sensing circuits are very similar to the open center circuit with respect to the required components. As with the open center brake circuit, the accumulator is the primary source for brake circuit pressure as well as power-off stopping. The difference is that the pump is a load-sensing pump and the accumulator charging valve is load-sensing. This type of system operates as a flow and pressure on-demand system. This diagram shows a single system charging. And here is a single system at standby. This diagram shows a dual system charging. And here is a dual system at standby. Meeting the needs of our customers is the #1 goal at MICO. If you need additional information, please contact us by internet, fax, or phone. MICO is ready to serve you.